So those who cannot participate right now, they can go through the video again. Okay, and now we are going to continue this exercise from today onwards. So probably we will be meeting day after tomorrow, and in next week we will be meeting on a regular basis. So today let us try to understand non-destructive testing. I think the the, the partial contents I have covered in the class before this outbreak. So non-destructive testing, you can see here that before mid-semester we studied destructive testing. So in non-destructive testing, the main purpose is to identify these two kind of defects, right? The one is a subsurface or a cross-section defect, which we cannot see. The defect must be in the cross-section, so we cannot see without breaking it. And the second one is a surface defect, that the defect may happen maybe on the surface in micron, but we cannot visualize by naked eyes. So these three defects, these two kind of defects can be identified as well as quantified by this non-destructive testing. So the first we can see here that magnetic particle test. So as the name suggests, magnetic particle. So first of all, you need to make sure that the component you want to test, the component or a part, it must be ferrous material, right? Because here the principle is magnetic particle. If the material of the component to be tested is a non-ferrous, then this test cannot be performed. So that you can see one of the limitation. So just try to have a look on this beautiful schematic. You can see there is a component, right? When this component is applied submagnetic fields through magnet, you can see here that there is a magnet. Okay, you can have this north pole and south pole. You apply current, electricity, right? And what will happen once you apply the current, and when this N pole and S pole is in contact with the workpiece to be tested, this is a workpiece to be tested. So what will happen? Once you apply the current, you will have the magnetic flux in a particular direction. So you can see a dotted line. So this magnetic flux will start flowing. So you can see that magnetic flux is produced, right? So here you can see these lines, straight lines are the magnetic flux. So you will have a repetitive pattern or fixed pattern. You can see here the straight line 1, 2, 3, 4, 5, this magnetic flux lines parallel to each other. Unless and until there is some kind of obstacle in form of defect. So let us take an example. You have the two defects. This is defect number 1, which is not on the surface, but which is far away from the surface, right? So you can say this defect as a cross section or a subsurface defect. And another defect you can see which is very near to the surface. So when the defect is there, a defect is nothing but an obstacle in the path of the magnetic flux being produced, right? So here you can see the magnetic flux line will get diverted based on the size and the shape of the defect of the material have. You can see here, it is little bit changed. Then after again coming back to the normal pattern. Again here, defect is there. So there is no magnetic flux line. It's getting surrounded by the shape of the defect, and it is again same thing, right? So you will have the magnetic flux line disturbed when it comes in contact with the defect. Now, how we can detect? Then after applying this magnetic field on a workpiece, then after this particle, you can see that is nothing but the magnetic particles. Okay, a magnetic particles means made of any ferrous materials. So you can have the magnetic particles in dry form or maybe in a slurry form. A slurry means you can mix with the liquid and it start flowing on the surface. I have a very big size component, right? Once the magnetic field is applied, then I can put maybe liquid slurry or a dry powder of the magnetic field. So what will happen? Wherever with the location, the magnetic flux get disturbed, all magnetic particles will get attracted and all of them will accumulated on that surface. So that will be the identification that, okay, at this location, the defect is existing. But this is a case of the surface defect. But if it is a subsurface, because the defect is far from the top surface and we are throwing or we are applying the magnetic particles on the top surface, so that may not have that effect. So here you cannot see, here this surface you cannot see any accumulation of the magnetic particles like this. So I cannot detect this defect, but I can detect this defect. So this MP test basically is suitable for ferrous materials and if you want to detect surface defects. But if the defect is not on the surface but somewhere here in the cross section, means far away from the top surface, then this test may fail. So this is about the magnetic particle test. Am I going well or not audible? Please tell me. Any one or two students can tell me so I can maintain the flow of the session. Okay, him. Thank you.